My name is Max Wallace, and my project asks, are West Virginia's spring birds changing their arrival dates as spring temperatures fluctuate? Why does this matter? Birds are ecosystem engineers. They disperse our seeds, they pollinate our flowers, and they control our insects. So if they arrive too early or too late, they can miss peak food supplies like caterpillars for their chicks, and bird chicks eat a lot of caterpillars. And that mismatch can ripple through forests and farms. So I set to answer two main questions. How have spring temperatures in West Virginia changed over the last 15 years? And if they have, are local bird species shifting their arrival dates in response? So, first off, how do birds know when to migrate? So they rely on environmental cues, primarily day length, which is a reliable long-term signal based on the Earth's 26,000 year axial precession. So consistent. Then there's temperature, which is a variable short-term signal. There's a different temperature every day, every hour, every minute. And there's also food availability and scarcity around the bird. So as climate change warms temperatures, birds may be tricked into migrating earlier, and alternatively, they may delay if other cues conflict because there's more signals than just that. But a NASA study in the U.S. found that warmer springs cause earlier migration. So I wanted to test if a similar pattern holds here in West Virginia. So let's check out our data. For the bird data, I used eBird, which is a citizen science platform from Cornell University where birders submit checklists. I focused on 5 fully migratory species in West Virginia. So we have the eastern phoebe, the wood thrush, the ruby-throated hummingbird, the red-eyed vireo, and the chimney swift, which is my personal favorite. After filtering for complete checklists, I kept 161,600 observations. It's a lot. From spring months, so that's just March, April, May, between 2010 and 2024. So that is 15 years. So for temperature, I used WorldClim monthly maximum temperature grids. These are like GeoTIFF files. These are images where I extracted each high temperature for each pixel within the West Virginia bounds and then calculated an average for each year across all of West Virginia, which we will see. To estimate the arrival day of the birds, I use the 5th percentile of the sighting dates each year. So like when 5% of the birds have been sighted for that year. It's a more robust way of doing it than just the earliest sighting because it reduces the influence of the rare early outliers and that sort of thing. So is West Virginia warming? Over this 15-year period we're looking at, average spring high temperatures in West Virginia fluctuated between about 66 degrees Fahrenheit and 72 degrees Fahrenheit. The trend line shows a slight cooling, though year-to-year variation is pretty large. 2020 stands out as a notably cool spring, and this tells us that local temperature trends over a short window like this can be a bit noisy, but I think that makes the bird response we'll see even more interesting. So I also looked up on the right here the whole year average highs for West Virginia, and as you can see, we are warming up. So that's regardless of season. So let's check on our bird arrivals. So here are the bird arrival day trends for each species that we're looking at. So lower day of the year on the y-axis means an earlier arrival. So though trend lines vary here, I found that 3 species, the chimney swift, the ruby-throated hummingbird, and the wood thrush, show a negative correlation with their arrival dates and spring temperatures, which we will see here in a bit. And 2 species, the red-eyed vireo and the eastern phoebe, don't show that same trend and even a slight delay in the case of the eastern phoebe. This tells us that not all birds are responding the same way to temperature. So when we overlay arrival dates with these spring temperatures for the same years, the relationship becomes even more clear. For most species, warmer springs are correlated with early arrivals. So if we look at something like the ruby-throated hummingbird, in warm years like 2024, it arrived about day 112. And in cooler years like 2014, it arrived around day 117. You can see some other species overlays here as well. Some pretty interesting matches, especially with the chimney swift, which has the highest correlation, which we will see. So, to quantify this, here are those correlations between the spring average high temperature and the arrival day for each of the 5 species. So, negative values means warmer equals earlier arrival, and positive values, which are the red ones, means warmer equals later arrival. So, the chimney swift and ruby-throated hummingbird show strong negative correlations. They arrive significantly earlier in warmer springs. The wood thrush also has a negative correlation, but it's a little bit weaker. The red-eyed vireo and the eastern phoebe actually show positive correlations. So in warmer springs, they tend to delay their arrival. So some species are highly sensitive to temperature with their migration cues, and others are not, or they respond in the opposite direction. This suggests that different species read their cues completely differently, or at least different ratios of them, different importance for each one, or that other factors like habitat or food availability are interacting, as we mentioned. So let's check out the geographic distribution of where our birds were seen. So this is a heat map, here in a second, of all the observations across the state. So unsurprisingly, sightings are concentrating around population centers like Morgantown and Charleston and Huntington, and around rivers and parks and that sort of thing. So there's also spots like Fayetteville here where it gets pretty heavy. Lots of birders. We have here, I believe this is Canaan Valley Resort. We got Spruce Knob below. And then Eastern Panhandle, lots of birding here. This is Harper's Ferry. This is where the Potomac meets the Shenandoah. So pretty interesting to see where the birds are being observed. So why does this matter? So when birds arrive earlier, they risk arriving before their food sources are available. So insects, flowering plants, that sort of thing. And that is called a phenological mismatch. So if chicks hatch when caterpillars are already gone, obviously their survival is going to drop. So for species that delay their arrival, they might miss the best nesting territories or face increased competition. Either way, climate change is disrupting the finely tuned timing that these birds have evolved over thousands and thousands of years. This is not just academic curiosity. Birds provide pest control for us and seed dispersal. And if their populations decline because of these mismatches that we're looking at, our forests and farms could feel the impact. So also want to acknowledge some limitations and talk about what we could do to study further. So 15 years is a relatively short period for climate trends specifically. It would be good to look at more, but I was limited by the amount of bird data if you go back before eBird was more popular. Also, eBird data itself is opportunistic, so there's more data in areas where there's more people looking at birds. And I only looked at spring arrival, so fall migration could tell a different story. So that'd be interesting to look at. I'd also like to check out precipitation as an additional variable. A less stronger signal, but a signal nonetheless. It would be interesting to look at in relation to the temperature and arrival day and all these other things. So in conclusion, yearly temperatures in West Virginia have warmed significantly over the past 15 years. Most migratory birds are arriving earlier in response to it, but not all of them. Some species are actually delaying, like the eastern phoebe and the red-eyed vireo. This suggests that the climate change happening is already reshaping bird migration in our state. And species are being affected differently. So if we're going to tackle this problem, we need to look at it on a species level at the very least. But that's all I have for you. Thank you for listening.